RLHF, I'll hand it over to Chris to walk you through this week's notebook.
Hey, thanks, Ancha. And now it's time for Lab 3.
All right. Welcome back, everyone. We are going to talk about Lab 3.
Time for Lab 3.
Lab 3 was one of my favorite to work on. This is where we get hands-on with reinforcement learning and human feedback, or RLHF. The purpose of this lab is to lower the toxicity of our instruction fine-tuned model from Lab 2. That was the output of Lab 2. That'll be the input to Lab 3 here, and we will lower the toxicity using a hate speech reward model where we want to optimize for not hate. We'll be using PPO that you learned about in the lesson, and we will wrap everything up with quantitative and then qualitative comparison of our detoxification process. Okay, let's install our Python libraries. Here we see that we're using PyTorch. We're also using the same transformers that we used in the previous labs. Of course, data sets to get access to our public data set. Evaluate so that we could run the Rouge score. PEFT is the parameter efficient fine-tuning library. And here's a new library called TRL. And this is what's going to give us access to PPO and a similar type of trainer and then training arguments. There's going to be PPO trainer and then training arguments, following the Hugging Face convention of trainer and training arguments. Let's do a bunch of our imports up here, familiar classes, the auto model for seek to seek. Note that there's a new one here, which is auto model for sequence classification. This is what we're going to use to load our Facebook binary classifier, sequence classifier, which when we give it a string of text or a sequence of text, it'll tell us whether or not that text contains hate speech or not with a particular distribution across not hate or hate. And of course, in this lab, we'll be optimizing for model from Lab 2 on with Reinforce 2 that with run the Rouge score with quantitative and then qualitative comparison of our detoxification process. Okay, let's be using PPO that you learned a comparison. of our detoxification process. Okay, let's install our Python libraries. Here we see that we're using PyTorch. We're also using the same transformers that we used in the previous labs. Of course, data sets to get access to our public data set. Evaluate so that we could run the Rouge score. PEFT is the parameter efficient fine-tuning library. And here's a new library called TRL. And this is what's going to give us access to PPO and a similar type of trainer and then training arguments. There's going to be PPO trainer and then training arguments following the Hugging Face convention of trainer and training arguments. Let's do a bunch of our PPO. And a similar type of trainer and then training arguments. There's going to be PPO trainer and then training arguments following the Hugging Face convention of trainer and training arguments. Let's do a bunch of our imports up here, familiar classes, the auto model for seek to seek. Note that there's a new one here, which is auto model for sequence following the Hugging Face convention of trainer and training arguments. Let's do a bunch of our import. Imports up here, familiar classes, the auto model for seek to seek. Note that there's a new one here, which is auto model for sequence classification. This is what we're going to use to load our Facebook binary classifier, sequence classifier, which when we give it a string of text or a sequence of text, it'll tell us whether or not that text contains hate speech or not with a particular distribution across not hate or hate. And of course, in this lab, we'll be optimizing for not hate. Here we see our PEFT and our LoRa config, which we saw in lab 2. Here we see the specific PPO trainer. There's also this other class, auto model for seek to seek language model with a value head. This is what's required when we do the PPO training, which we'll see in a bit. Also this length sampler, this will give us the ability to filter or actually sample from our text various lengths. So we don't actually have to pull in the entire sequence. We can pull in just, different samples. And this comes in handy when we're trying to either sample from our full data set, even though it's beyond the 512 context window. We may want to sample up to 512. In some cases, you would actually just throw away samples that are larger than 512. With length sampler, for example, we can just sample the first 512 or take samples within the sequence, maybe not starting from the beginning, but maybe in the middle or towards the end. And so length sampler is kind of nice. Here we see PyTorch, the evaluate. If you haven't seen this before, TQDM, this is where typically when you see progress bars showing up in Jupyter Notebooks or on your command line, they come from this TQDM library. As before, we're going to load our data set and then eventually our model here in a sec. We have this build dataset Python function that we've defined that can do the length sampling using that length sampler that was mentioned up above, can also convert our text into those vectors, also called tokenizing. So here's where we start to see a little bit more complexity in our code. The first couple labs, we stayed pretty simple. Lab 3, we start to do a little bit more Pythonic type stuff. We have nested functions here to, tokenize. We're starting to combine things into single functions. And we're going to just say, build the data set here. We're going to give it the model name. We need the model name to know which tokenizer to use because, again, these models each have their own tokenizer. If you try to mix and match tokenizers between different model types, that's not good, and you'll see some pretty bad results. One other feature of this build dataset function is that we're going to wrap our dataset into this instruction prompt. So this is something that we did in the first and second lab. So we're kind of combining it all into one single function here. Now, this is the model that we trained in the second lab. So I'm pulling it from cloud storage here. We pull it down, and it should be in a folder here called PEF Dialog Summary Checkpoint. Let's crack it open just to see. Here's the adapter model.bin. Again, that's the thing that's only 14 megabyte. And here's our handy print number of trainable model parameters function that we'll use from time to time to get fancy and see when we're using PEFT. Throughout this entire lab, we will be using PEFT. So for the most part, we'll be just training and fine-tuning a very small percentage of our model size. So here, once again, 1.4%. Now, here's where we have to use this variant of the auto model for seek-to-seek LM, which is with value head. So this is related to how PPO actually performs its training. And here, by the way, just to be clear, we do say is trainable equals true. And that's on purpose because we are actually putting the model into fine-tuning mode. And then later on, when we go to make predictions and to generate summaries, we will set that to false. So if you notice, this number is a little bit higher than it was in lab 2, and it's higher by exactly 769 parameters. And so let me explain what's happening there. 768 of those parameters are from the value head. Actually, all 769 come from the value head. It's 768, which is the dimension of the value head plus our bias. And bias is very important, by the way. It's just because it's always there, people just tend to not include it in their casual conversations. Now, I skipped over this create reference model. This actually comes from TRL. We had imported this up above. And what this is doing is, as you learned about in the lesson, when we do RLHF, you can specify a base model that's used with KL divergence to make sure that while the reward function is being optimized, right? While we are optimizing to maximize the reward, which in this case is not hate speech, we don't want to just wildly hack that reward and just generate things that are not hate, but that are not relevant to the original. So said differently, when we go to train, we're going to pass in two models, what's called a reference model, which is a model that is not going to be fine-tuned at all. Not even with PEFT. It's just the original instruction fine-tuned model that was the output of lab 2 that's now the input for lab 3. And then KL divergence is used to compare what would the original model have generated versus what would the current PPO model have generated, and then keeps things sort of in line that way, and then minimizes the model's ability to perform the reward hacking. So we'll see it here in a bit. Here's where we're actually going to load what I'm calling the toxicity model. Again, this comes from Facebook. It was designed to detect hate speech. It's based on BERT. Facebook has a variant of BERT called Roberta. So this model is on the order of millions of parameters, not in the billions and billions like the large language models that we have today. Now that that model is loaded, so again, here's where we use the auto model for sequence classification. So this is a classifier. In this case, there's only 2 labels, and that's what is going to make this a binary classifier. It's not hate or it's hate, and we'll see that in action here. Here is a sample non-toxic text. I want to kiss you. Pretty friendly piece of text here. And we see different ways that this model can actually generate output for this text, can actually classify this text. Just know that the first spot, the most important thing is the first slot that this model can generate, the first class is not hate. And that becomes very important. Hate is in the second position, right? Or 0 index, it's the first index. So 0 index is not hate, first index, the 1 index is hate. And we see that not hate is very high. So these are the logits, right? We can also, of course, perform a softmax on those logits. And we see that, that the probability of this text being not toxic or not hate is essentially 100%. The probability that this model is, or that this text is hate, is very close to 0. In our PPO training, we will actually use the logit. And it's very important to get the index right. And I say this because if you accidentally optimize for the wrong index, you can actually generate text that's more toxic, which is not what we're trying to do here today. So I call this out because, and one thing that I did to actually make this more explicit is I call out the not hate index equals 0. And the reason why this is confusing is in a lot of cases, the sort of positive class is in the second position and the negative class is in the 0th. And so if you go and copy somebody else's code or you find an example online or you have a friend help you, you might accidentally mess up which index. Here is an example of toxic text. And now keep in mind, I did have to use a bad word here to actually trigger this. And so let's run it there. And so here we see 97, almost 97.5% probability that this is toxic or hate speech. Now, hate speech is extreme. And so I do caution if you do try to play with this example, that oftentimes you do have to be extreme to trigger the hate flag. So the good news is we're not optimizing for the hate flag, we're optimizing for the not hate flag. So let's keep going. One thing we haven't shown much in these labs is what's called a Hugging Face inference pipeline. And so this gets imported up above, this was imported. And here we're creating what's called a sentiment pipeline. And the real value of these Hugging Face pipelines, this is from the Transformers library, the real value is I can just say this is a sentiment analysis problem, basically 2 classes, and I give it the name of my model, and then I can use this, and I don't have to call all those low-level model.generate and do the tokenizer and all that stuff. This will actually do it all for us. So again, we did not use these in the first and second lab. We are using it here just to reduce the complexity of this lab and really, really focus on the RL part of it. But I do want to show you that there are these things called the inference pipelines, and they're very, very handy. You can mix and match as we're doing in this lab here. Sometimes you can use them, sometimes you don't have to use them. Here we are setting up a toxicity evaluation mechanism. And we're going to reuse the evaluate Python library, which does have a first class knowledge of toxicity. And so, of course, when we set this up, we have to give it the toxicity model, which in this case we're using Facebook, Roberta hate speech model. The other interesting thing is that we have to pass in the toxic label. In this case, the toxic label is hate. And we will use this evaluator later on when we compare before and then after our PPO, our reinforcement learning with human feedback. Here we see for the non-toxic text, which we specified up above, the I want to kiss you, and the toxic text, we see that these scores are consistent with what we were expecting. Here is a convenience function where we pass in the model, pass in the data set. We can even tell it the number of samples to try, and to calculate a mean toxicity score along with the standard deviation for a whole bunch of summaries that are generated tell us what is the mean toxicity score. And so the goal is to reduce the mean toxicity score after we do PPO. And so here we see what the mean and standard deviation toxicity is before we perform our detoxification to reduce the toxicity of our generated summaries. So here we see what the mean and standard deviation toxicity is before we perform our detoxification to reduce. Reduce the toxicity of our generated summaries.
Okay. Select IDs, images, model IDs, properties, subjects.
Here we're going to initialize the PPO trainer. We have a PPO config as well too. These are really just sort of standard learning rates. We are doing a small number of the PPO epochs, again, just to keep the time for this lab down to a reasonable number. Batch size here, 16, not too bad. And you can actually play with, some of these values when you get into the lab. Here we see PPO trainer takes the reference model. So this we used up above when we called create reference model, and that's essentially the original model that was the output of the lab 2. And that's what's going to be used for KL divergence during PPO training. Now we actually fine-tune the model using RLHF. This is the exciting part. And so here we see KL divergence, which is something we want to minimize, just like you learned in the lesson. We don't want the KL divergence to go too high. That means that the model is starting to hack the reward function, and that's not good. It's just generating things to make the reward happy. It's not generating things that are actually similar to the original text that's being passed in for summarization. And we're trying to maximize happy. It's not generating things that are actually similar to the original text that's in the lesson. We don't want the KL divergence to go too high. That means that the model is starting to hack the reward function, and that's not good. It's just generating things to make the reward happy. It's not generating things that are actually similar to the original text that's being passed in for summarization. And we're trying to maximize the mean return. These are some of the PPO reinforcement learning concepts that you learned about in the slides. Maximize the advantage. And this will run for about 20 minutes or so. So go grab a cup of coffee. And what's happening here is we're grabbing each of the samples that we provided from our dialogue data set, and we're making we're summarizing the text. We're using the sentiment pipeline that we created up above that's going to classify both what's called the query, which is the prompt, and the response together. So we're going to zip those two together using the Python zip. And we have query response. We're going to pass that pair in to the sentiment pipeline and ask the pipeline, is this toxic, is this hate, or is this not hate? That then gives us the logits for those query response pairs. We're going to pull out the not hate score, and we're going to pass all of this in to the PPO trainer. So we're going to give it prompt, we're going to give it the response or the summary, and we're going to give it the score. All of those three go in as lists, as batches, into our PPO trainer that's then going to perform a PPO step to minimize the loss function as you saw in the slides. And this is where the actual gradients are being updated. And now keep in mind that we're using PEFT. And so we're not actually modifying the base LLM parameters, PEFT. We are just modifying the 1.4% LoRa PEFT adapters that are being used during this fine-tuning process. And we will run this for a bit We see KL divergence is, relatively stable around 27, 28, 29. It goes up, it comes down. That's PPO trying to keep things balanced. And once this is done, we will compare the model quantitatively as well as qualitatively. After about 10 iterations, we can compare the model that has been detoxified or has reduced toxicity as compared to the original model. And here we could do this qualitatively by comparing the previous response to the response after. So here we see that the reward has actually gone up in a number of cases of these examples. So query is the original text that we want to summarize, the original conversation wrapped in that instruction prompt. And we see the response before, we see the response after. And we see that the model has determined that the reward model, the hate speech model, has determined that the reward actually is more positive in a number of these. If you were to train longer and had more time, you would see this a relatively significant difference. The other thing to mention is because the reward model is so extreme that really to get the most benefit, you would start with a relatively toxic data set, which this is not a relatively toxic data set, and then you would see a much larger difference. But here we see directionally by doing PPO and using the reward function that we're using, the reward model for the hate speech, that we can actually lower the overall toxicity of our model responses by a decent amount.